Hello everyone, I hope you all are well and making progress in life. Here is Priyanshu and welcome to the Infinity Mind. So today I will be solving the problem combination sum 2. So the problem statement says that given a collection of candidates and a target number target, find all the unique combinations in candidates where the candidates numbers sum to target and each number in candidates may only be used once in the combination. All right, and we have to keep note that the solution set must not contain duplicate combinations. All right, so the question is just similar to the combination sum 1, that we are just given the candidates array and target, and we have to return a power set, we can say, or any set. We have to return a set which stores all the sets where elements sum to target, and the only change here is that we don't have the flexibility to choose infinite number of elements. We just are given these elements and we can choose these elements only once. Also, we the elements here are, we can see, repeated also. One is repeated twice, so we have to keep in mind that the sets which we are storing in the resultant data structure, they should be unique. They it should not store duplicate combinations should not be here. So how we can solve this? So this is just similar to combination sum 1. I am taking this second example, this example 2, because it is short to explain. So this is the candidates array and target is 5 here. We can see candidates array is this and target is 5. Now what I will do, I will use the same technique, pick and non-pick. So first of all, my I will be at first of all I will have option to choose I is equals to 0, and I will choose I is equals to 0th element, or I will not choose. So my target is 5. Now I have the option, if I choose I is equals to 0, then I will have in the set 1, and target will be now 5 minus the current element, that is 1, that is 4. So now target is 4, and now I have the option to choose I is equals to 1th element. Now I have chosen this. Now I have option to choose this 2. So now if I choose 2, so the target will be 2. All right, because 4 was already there and I took 2. Now target reduced by 2, so target is 2 now. Now again I have option to choose the third element, so my set will become 1 comma 2 comma 2, and now target is 0. And when target is 0, this is the base case. We know that when target is 0, we have found a set where all the elements are summing up to 5. We can see 1 plus 2 plus 2 is 5. So we will store this in a data structure. All right, and we are good to go here. Now in the case when we have to skip, so we can see that if we have to take elements, we can take any element, 1 2 2 2 5, we can take any element. But when we have to skip, uh, this skipping method is just similar to subset 2, which we solved earlier. So here also we will skip the duplicates. So while skipping, so we can see that if we skip I is equals to 0th element, our set will be empty and target will remain 5. Now where will be my I was earlier here and I will be here now. So but before moving I further forward, we will check that the new element should be the see, we are skipping I is equals to 0. We are not taking I is equals to 0th element. Now instead of saying that just move I to I plus 1, also skip all the duplicate elements, also skip all the duplicate ones. This is just the similar logic to subset 2. So we have to skip the duplicate elements, otherwise it will give the same answer. All right, so we are skipping the duplicate ones here, so we can see that we have only one, and we our I will be at 1 now. All right, now I have option here to either to take I is equals to 1th element, that is 2, or not to take. So if I have to take, I will take without any problem, because I can take any element. So if I take 2, the target will be 3, and now my element will be at I is equals to 2th element. So again I have two options, either to take it or not take. So if I take it, the target will be 1, and I will be equal to 3. Now when again I have option to take I is equals to 3 or not. So if I take 3, we can see that this, my target is 1 and the element is 2. My target is 1 and element is 2, so we will not go, otherwise my sum will exceed target. So I will return from here when my target is less than the index element. And in the skipping case, when we are skipping I is equals to 2, then we will also skip those I which are duplicates. So I is equals to 2 was what? I is equals to 2 was this. So while skipping this I is equals to 2, it means that we are skipping 2. Now we should also skip this 2. Instead of moving to this 2, we should also skip this 2 and we should move here. Now our I will be at 4, 0, 1, 2, 3, 4. So I will be at this. All right, now my target will be 3. So again I have two options, either to choose I is equals to 4 or not. So if I choose 5, but we can see target is 3 and it is the element 5 is greater than 3, so we will return from here. Now here also we can see that if we do not choose I is equals to 1th element, if I do not choose this I is equals to 1th element, and I will be having an empty subset. Now my I is equals to 1 was here. All right, and if I do not choose this, I will be have empty subset. Now I have two options, either to take this or not. So if I do not take, I have to skip I is equals to 1th element. So I will also skip all the duplicates. So basically I will be here now after skipping all the 2's. So I will be at 5. So here if I take 5, the set will become 5 and target will be 0. And we can see when target is 0, we have found our answer, and I will store this answer and return. And if I do not take this, so we can see that we will reach I is equals to 5. And see, our element was here, and if I choose this, this will give this answer. And if I do not choose, I will say that okay, skip this I, but also skip the duplicate elements. So after skipping the duplicate elements, my I will be here. All right, so we can see that I is out of bound, so I will return from here. So we can see that we have found two answers, 1, 2, 2 and 5. And here also we can see that there are two possible sets, 1, 2, 2 and 5. So this we have to return, storing it in a data structure vector of vector. All right, so we can see that I just use the same logic of combination sum 1 and subset sum 2. Combination sum 1 because I will write the same logic uh, for finding the sum, but here the twist is that we have limited elements and we can choose only once. And also subset sum 2 because their duplicate combinations we have to avoid. So here also I will avoid the duplicate combinations. So I will while skipping any element, so while skipping this 2, I have to also skip these 2. So this explanation I have also explained well in subset 2 problem. You if you want to, I mean, if you have any problem in understanding this skipping logic, you can just have a look, and or on any Google or YouTube. So we can see that this is just the logic. And uh, if I go and implement this, so int n is candidates dot size. So what I was doing, that first of all, yes, the array is not sorted, and if I will not sort, these two ones will not be closures. So I have to sort the candidates array also. So I will sort them candidates dot end. Now what I was doing, I have to store them all the subsets. So I will create current, and I will also create a resultant vector, and now I will call just this solve function, and there I will pass our first index, that is 0, and our current subset, and our resultant subset, and our candidates array, and our target, and I am passing size that is n, and at last we just have to return resultant. Now I will write the sort function. So solve function, I will write void solve. Here I'm passing index, and then I'm passing this current, and then I am passing this resultant, and then I'm passing candidates and target, and then I'm passing n, and I will not forget to pass this by reference. And then I will write the logic. So what I said, that if target has reached 0, I will say that push back our current subset directly and return. Now our another base case was that if I is greater than equal to n, I mean if it is out of bound, we can just return. Now what I said, that else I will check if the candidates of I. So here I want to say that if we pick element, so after if I pick element, so first of all I will check if the current element is less than equal to target or not. So if it is less than equal to target, I will push that element into my current subset, that is candidates of I. It should be candidates of I, and then I will call solve function to just go and explore other elements. So I will just call the same. So I will go to I plus 1, and current, and then resultant, candidates, target, and yes, target is reduced because we have picked the candidates of I. So candidates of I, target minus candidates of I, and at last n. And now if we do not pick, so if we do not pick, no pick, so we should remove the element also. If we have taken the element, we should remove the element also from the current subset. Then only we should check. Now if I do not pick, so if I do not pick, what I will do, first of all I will skip all the duplicates. So how can I skip the duplicates? I will just say that if candidates of I is equals to candidates of I plus 1, just keep moving I, and then my I will be at the correct position. I mean correct position minus 1. If I am here and I have to skip duplicates, I will be here. Now I can call 5. So I will just call the same function. So I plus 1 will be called, current will be there, resultant, candidates, target will be target now because we have not taken the element. And yes, now if I run this and check if we haven't made any mistakes, so if I submit this and check if we are able to pass all the test cases or not, so we can see that we have solved this problem now successfully. So we can see that I have written just one single code while loop and we are good to go. And if I tell you this time and space complexity, we all know from combination sum that time and space complexity is just same. We have added just one line of code. So time complexity we are exploring, we can say that for every element there are two options, either pick or not pick. So if there are total n elements, we have time complexity of we go of 2 to the power n, and while pushing back the current subset into the resultant. So this will take, if I take the average length of all the subsets as k, so time complexity will be big of 2 to the power n into k, and this is the time complexity. And space complexity, we all know that we are taking space for storing the results. So how many total combinations are there, we cannot what do we say, we do not know. And so I'm saying that if there are total x combinations and each average length if is k, so the space complexity is big of x into k. So this was all about this problem. I hope you understood. Thanks for watching. Till then, keep learning and keep upgrading yourself. See you in the next video.